Okay, so the question is, which of the following changes in conditions would increase the volume of a fixed mass of gas? So the mass is constant. Mass is constant and we have to increase the volume of the gas. So we have to check the pressure and temperature condition that would result in the increase in the volume of the gas. So from the ideal gas equation we know PV equals to nRT. Now what is N? N is mass over molar mass and multiply RT, that is equals to PV. So we can restructure this formula, M over MR RT, and we bring the P down. So we have to increase the volume and M is constant. M is constant, right? Fixed mass of gas, MR is constant. Okay, then R is constant. So to increase V, what we have to do, we have to increase T and we have to decrease P. Okay, so what do the first option say? First option say we are doubling the pressure. No, we have to decrease the pressure. So first option is not correct. Then in the second option they are saying that they decrease the pressure, means they halve the pressure and they halve the temperature also. No, we have to increase the temperature. So temperature cannot be halved. Then third option says they double the pressure. No, we don't have to increase the pressure. So this is wrong. Then in the last option they say that they halve the pressure, means they reduce the pressure, and temperature they double, means they increase the temperature. So this is the correct option. Okay, so the question is, the temperature in Kelvin of 1.0 dm cube of an ideal gas is doubled and its pressure is tripled. Assuming no changes in the mass of ideal gas, what is the final volume of the gas in dm cube? So the temperature in Kelvin of 1 dm cube. So the volume is given 1.0 dm cube and temperature and the pressure is tripled. So we consider that the initial conditions, my temperature is T, volume is V, and the pressure is P. Now in the final condition, what they did, they doubled the temperature. So temperature become 2T and the pressure is tripled, pressure become 3P, and we have to find the volume. What is the volume? This says that the mass of the gas is constant, M is constant. So M is constant means moles will be constant, because moles equals to mass over molar mass. Molar mass is constant and M is constant, so N will be constant. Okay, so we can use the ideal gas equation, PV equals to nRT. So what is my pressure? Pressure is P. What is my volume? Volume is 1. Let's say the moles is N, which is constant, and R is a gas constant, and my temperature is T. So this is my one equation. In the final condition, let's apply the ideal gas equation. What is my pressure? Pressure is 3P. We have to find the volume. So VF, final volume, we have to find, and number of moles remain the same, R is same, and temperature is what? 2T. This is my second equation. So what will I do? I divide equation 2 by equation 1. So if I divide equation 2 by equation 1, so 3P VF divided by P into 1 equals to NR 2T divided by nRT. So we just divided equation 2 by equation 1. So what we see here, we can cancel P cancels out, nR cancels out, T cancels out. So what is left? So we are left with VF, that is a final volume, equals to 2 by 3. So this is the answer. So the option B. So option B is correct. Okay, so the question is, four identical containers under the same conditions are filled with gases as shown below. Which container and contents will have the highest mass? So same conditions means same conditions of pressure, temperature, and since all the four flasks are of same volume, so we have the same volume as well. Now we know ideal gas equation PV equals to nRT, right? So my pressure is constant, my temperature is constant, volume is constant, and of course R is constant. So only N is left. And what is N? N is mass over molar mass. So out of the four containers, which one will have the highest molar mass? Will have the highest mass. So we will just find out the molar mass of nitrogen. 2 into 14, 28 grams. For oxygen is diatomic, 2 times 16, 32 grams. And ethane C2H6, 2 times 12 plus 6 times 1 is 30 grams. And neon is monoatomic, it's a noble gas, so its mass is 20 grams. So which one is highest? Oxygen. So the correct option is B. So the question is, which statements are correct about Avogadro's constant? First, it is a number of ions in 12 gram of sodium hydride. So sodium hydride, NaH. So how many ions are there? If sodium hydride dissociate, it will give me sodium ion and hydride ion. So 1 mole of sodium ion will give me 1 mole of sodium and 1 mole of hydride ion. So what is the molar mass of sodium hydride? 23, and hydrogen 1, 24 grams. Okay, so it means that 24 grams of sodium hydride means this is equals to 1 mole, right? 1 mole of sodium hydride is the molar mass of sodium hydride, and 1 mole of sodium hydride will give me how many total ions? One molecule is giving me two ions, one sodium ion and one hydride ion, and I know that 1 mole of sodium hydride has Avogadro's number of molecules, right? And 1 molecule of sodium hydride has how many ions? 2 ions, right? Has 2 ions. So I say 1 mole of sodium hydride will have 2 times Avogadro number of ions, right? And what is 1 mole? 1 mole is 24 grams of sodium hydride will have 2 times Avogadro number of ions, total ions, right? So they are asking how many number of ions are there in 12 grams. So 12 grams, which is equals to half mole of sodium hydride will have 2 multiply sodium Avogadro's number divide by this multiplied by this. So so this equals to Avogadro's constant. So it means first option is correct, because they are asking which statement is correct about Avogadro constant. So this will give me Avogadro constant. Now second option is, it is a number of molecules in 22.7 dm cube of hydrogen gas at 0 degree Celsius and 1 atm. So 0 degree Celsius and 1 atm is STP condition, and we know that 1 mole of gas occupies 22.7 dm cube at STP, right? This is given in your data booklet. Also this you can find out from PV equals to nRT equation. So that will be 1 mole, right? So 1 mole of hydrogen gas will give me this much volume, and 1 mole of hydrogen gas has Avogadro number of molecules, so this option is also correct. Third option, it is a number of atoms in 12 gram of carbon 12. Of course, this is the definition of Avogadro's constant. So Avogadro's constant is a number of atoms in 12 grams of C12. So all the options are correct. So the correct option is D option. Which of the following are assumptions of the ideal gas model? First, the volume occupied by gas particles is negligible. Of course, this is correct. So in ideal gas, the particles or molecules of the gas occupy least volume or negligible volume. And there is no intermolecular force of attractions between gas particles? Yes, in case of ideal gas. Zero particle movement? No, there is particle movement, there is collision. So the correct option is A. Only first and second statements are correct. So the question is, the temperature of an ideal gas is 27 degrees Celsius. What is the temperature of the gas after the pressure is doubled and volume is tripled? So the temperature is given to us. T is 27 degrees Celsius. We have to change into Kelvin. So 273 plus 27, that is 300 Kelvin. Okay. So in all the ideal gas equation laws, we have to apply temperature in Kelvin. So let's say the pressure is P and the volume is V. This is my initial condition. And in the final condition, what I have, they say that we need to find the temperature TF. We need to find. Pressure is doubled, so pressure become 2P, volume become 3P, right? So we can just apply the combined gas law. P1 V1 over T1 equals to P2 V2 over T2, right? So we put P1, so P1 is P, V1 is V, T1 is 300, and P2 is 2P, and V2 is 3V, and T2 is TF, which we need to find. So now P cancels out with P, V cancels out with V, and this becomes, we can cross multiply, right? So TF equals to 2 times 3 multiplied by 300. So this becomes 1800 Kelvin. This is in Kelvin, right? But the options they have given are in degrees Celsius, so we have to subtract 273 from this, so we will get 1527 degrees Celsius. So this is the answer. So the correct option is C. Okay, so the question is, a gas syringe contains 40 cm cube of an ideal gas at 27 degrees Celsius. What will be the volume of the gas after it is warmed to 57 degrees Celsius at constant pressure? So P is constant, okay, and initial condition is given. The volume is 40 cm cube, temperature is 27 degrees Celsius, so we change into Kelvin, so this becomes 300 Kelvin. Now in the final condition, the volume we need to find. What is the volume of the gas? And when it is warmed to 57 degrees Celsius, so we change to Kelvin, so it becomes 330 Kelvin. Now we will apply the Charles law. V1 over T1 equals to V2 over T2, okay, because pressure is constant, so we just plug in the values. 40 over T1 equals to Vf over T2, 3T0, so it becomes Vf equals to 40 over 30 multiplied by 330. I just cross multiply this, so 0 0 cancel, 0 0 cancel, 33 11, so it is 44 cm cube. So the correct option is C option. Okay, so this is an interesting question. Which of the following balloons contains the largest number of hydrogen atoms at constant temperature and pressure? So temperature and pressure are constant, so it means we can apply the Avogadro's law. Avogadro's law. So what is Avogadro's law? Avogadro's law states that at constant temperature and pressure, equal volumes of all gas contains equal number of molecules or the moles. So here the volumes are given, so the ratio of the volumes will be same as the ratio of the moles. So I can say this is my hydrogen, ammonia, methane, and hydrogen fluoride. So the ratio of the moles will be same as the ratio of the volume. So the moles I can consider 2, 2, 2, 1 and 4. This is the moles ratio. Now I know that 1 mole of hydrogen has uh, how many atoms of hydrogen. So 1 mole hydrogen has how many atoms of hydrogen? 2 times Avogadro number of atoms of hydrogen, right? So therefore 2 moles will have how many atoms of hydrogen? 2 times Avogadro number of hydrogen. Okay, now I know that 1 mole of ammonia has how many atoms of hydrogen? So 1 mole of ammonia has 3 times Avogadro number of atoms of hydrogen. So therefore 2 moles will have how many? 2 times 3 into Avogadro number of atoms. Now in methane I know that 1 mole of methane has 4 times 1 mole of methane has 4 times Avogadro number of atoms of hydrogen. Therefore 1 mole will have how many? Same, 4 times Avogadro number of atoms of hydrogen. Now I know 1 mole of HF has how many atoms of hydrogen? Avogadro number of atoms. Therefore 4 moles will have how many? 4 times Avogadro number. So which one is the highest? The highest is this 6Na. So the correct option is B option. Okay, so the question is, which of the following statements about ideal gas are correct? At constant temperature, when T is constant, what is the relation between pressure and volume? PV is constant at constant temperature. So first option is wrong, right? Because this is my Boyle's law. Now at constant volume, when volume is constant, what is the relation between pressure and temperature? P over T is constant. That is my Gay-Lussac's law. So this is correct. Now at constant pressure, when P is constant, what is the relation between V and T? V1 over T1 is constant. So V over T is constant. This is my Charles law. So this is correct. So which of the statements are correct? Second and third. So second and third. Okay, so this is another interesting question. The volumes and pressure of equal masses of 4 gases. So the masses are equal for all the 4 gases. Nitrogen, methane, chlorine and neon are separately investigated uh, at constant temperature. So temperature is constant and mass is also constant. The results are plotted on a graph of PV versus V. All 4 gases behave as ideal gas under the condition chosen. Which plot shows the result for neon? Okay, so temperature is constant, right? T is constant and the mass is constant. Mass is also constant. So if I have this ideal gas equation, PV equals to nRT. So in this equation my T is constant, gas constant is also constant, and M, mass is constant. So moles, how the moles are related to mass? Mass over molar mass, right? So my equation reduces to this one. So in this equation my T is constant, R is constant and M is constant. So it means my PV only depends on molar mass, MR. So if MR is more, PV is going to be low because it's an inverse relation. So PV will be low if MR is more, and if MR is less, PV will be more. Okay, so we have to find the MR of all these gases. So MR for nitrogen is 2 times 14, so that is 28 grams. MR for methane is 12 plus 4 is 16 grams, and chlorine is 35.5 multiplied by 2, that is 5 to the 10 0 1, 5 to 10 11 171 grams, and neon is 20 grams. Okay, so more the molar MR, more the molar mass, less will be PV. So D will have the least MR, right? No, D will have the highest MR because PV will be lowest. So highest MR, D. So which one has the highest MR? Highest MR is chlorine. So this is chlorine. Then next C will be less MR than this one, chlorine, that is nitrogen. Then after that B will be 20 grams neon, and A will be our methane because it has the least MR. So least MR means highest PV, right? So they are asking which results show the result for neon. So correct option is B option. Okay, so the question is ammonium carbonate decomposes readily when heated. So the equation is given to you. Determine the volumes in dm cube at STP. STP is given of the individual gases. So what are the gases? Ammonia and CO2. Produced on decomposing 2.25 grams of ammonium carbonate. So we are decomposing 2.25 grams of ammonium carbonate, and ammonia and CO2 will be formed. We have to find the volumes of these gases at STP. So first of all, we will find the molar mass of ammonium carbonate. So what is the molar mass of ammonium carbonate? So molar mass is 2 times nitrogen is 14 and hydrogen 4 plus 12 plus 3 times 16. So this comes out to be 2 times 18 plus 12 plus 6 3 is 18, 1 16 3 is 48, and 18 2 is 36 plus 12 plus 48. So that is 36, 12, 48, 6, 1, 4 to 8, 9, 96 grams. Okay, so how many moles of ammonium carbonate are there in 2.25 grams of ammonium carbonate? So the moles of ammonium carbonate in 2.25 grams will be mass over molar mass. Okay, so this is the moles. So how much is it? So this comes out to be 2.25 divide 96, 0 0.0 0.023, 0.023, and okay. Now this one is how many significant figure? Numerator is 3 significant figure, so our answer will be in 3 significant figures, this much moles. Okay, so 1 mole of ammonium carbonate is giving me 2 moles of ammonia and 1 mole of CO2. So therefore the moles of ammonia formed will be 2 times of 0.0234. So that comes out to be 0.0234 multiply 2. So that comes out to be 0.0468 moles. Okay. Now 1 mole of ammonium carbonate is giving me 1 mole of CO2 gas. Therefore the moles of CO2 produced will be same as ammonium carbonate. Now at STP we know that 1 mole of gas occupy 22.7 dm cube, 22.7 dm cube of volume at STP. So for this mole and this mole, how much will be the volume? Because we need to find the volume, so we convert. So therefore the volume of ammonia will be 1 mole is occupying this much at STP, so this much moles will occupy how much? So 22.7 multiplied by 0.0468 So that comes out to be 0.0468 multiply 22.7, so that is 1.06. We have to report in uh, three significant figure, because this is three significant figure and this is also three significant figure, so we have to report our answer in the least significant figure. So this is, and the volume of CO2 will be 22.7 multiplied by 0.0234. This will also be in three significant figures. So this comes out to be 0.531 dm cube. So this is the answer. So the question is, a closed steel cylinder contains 0.32 mole of hydrogen gas and 0.16 mole of oxygen gas. The volume of cylinder is 25 dm cube and the initial temperature of the gas mixture is 25 degrees Celsius. Calculate the initial pressure of the gas mixture in the cylinder. So the moles of hydrogen is 0.32 and the moles of oxygen is 0.16 moles. So when we mix together, the moles will be added up. So the total moles, because 1 kg apple and 1 kg banana we put together, so how much is total kg? So we are going to add these two moles. So this become 0.48 moles. Volume is given 25 dm cube and the temperature is given. Temperature is 25 degrees Celsius and we change into Kelvin. 273 plus 25, that is 298 Kelvin. Okay, so this is temperature, volume and moles. We need to find the pressure, so we just apply the ideal gas equation, PV equals to nRT. So we need to find pressure. So pressure is P, volume we are putting in dm cube, so pressure will come in kilopascals, 25, N is 0.48, R 8.31 and T 298. So from here pressure comes out to be 0.48 multiply 8.31, 298 and 25. So since we have the least significant digit is 2, so we will report our answer in two significant figures. So we are multiplying 0.48 with 8.31 multiply 298 divide by 25. So in the two significant figures the answer is 48 kilopascals. So this is the answer. So why we are reporting in two significant figures? Because when we are multiplying and dividing, we have to report our answer in the least significant figure. So how many significant figure here? Two significant. How many significant figure? 3. Here 3 and here 3. So we have to is 2. So we have to report our answer in two significant figures. Okay, so what is the next part? Next part is when the gas mixture is ignited, both reactants are consumed. So we have hydrogen and we have oxygen. So this will give me water, 2 and 2. So this is a balanced equation and we have 0.32 moles of hydrogen and 0.16 moles. So both will be consumed because the ratio of the moles is same as the reacting ratio of the moles. So the moles of water formed will be 0.32 moles, because 2 moles hydrogen will give me 2 moles of water. So this much moles of water will be formed and the temperature after ignition is 800 degrees Celsius. So we add 273 to make into Kelvin. So this much Kelvin, moles is given and the volume remains the same for the container, 25 dm cube, we need to find the pressure. So pressure will be N R 8.31 into T, temperature 1073, divide by volume. Volume is 25. So pressure will come out to be in kilopascals. Now we will again report our answer in two significant figures. So this is 0.32 multiply 8.31 multiplied 1073 divide by 25. So this will come out to be 110 kilopascals. Yeah, so this is the answer. So why we are reporting our answer in two significant figure? Because this is two significant figure, this is three significant figure, this is four significant figure, this is two significant figure. We have to report our answer in the least significant figure when we are doing multiplication and division. So this is the answer. Okay, so the question is at 338 Kelvin, pure PCl5 gas present in a rigid flask has a pressure of 25.5 kilopascals. At 480 Kelvin, the gas is completely dissociated into PCl3 and Cl2. What is the pressure in the flask at 480 Kelvin? So suppose this is my flask here, and here I have PCl5. Temperature is 338 Kelvin. Okay, temperature is given. Pressure here is 25.5 kilopascals. Right, this gas completely dissociates into this. So the volume of the gas container remains the same because my container is same. It's a rigid container. It will not change the volume. So volume is same. Now the volume is same for the container V. The PCl5 decomposed into PCl3 and Cl2 inside this. So we need to find the pressure now when it decomposed. The temperature is now 480 Kelvin. So what we see here? We see here that 1 mole of PCl5 gives me 1 mole of PCl3 and 1 mole of Cl2. So if I have X moles of PCl5, this will give me X moles of this and X moles of this. Means my moles are becoming double. This is completely decomposing into this and this. So my moles are becoming double. So if I know the moles here, so here the moles will be twice, 2 times. Right? Because PCl5 completely dissociates into PCl3 and Cl2. And 1 mole is giving me 1 mole and 1 mole. So n moles will give me n mole and n mole. Means 2 n moles. So can I find the moles here? So considering my volume is V, P is given and T is this. So 25.5 pressure into volume V. Suppose the moles is N, R is gas constant and temperature is given 338. So N comes out to be 25.5 V over 338 R. So these are the moles of PCl5 present initially here. So after decomposition at 480 Kelvin, the moles will become double. So my moles will be 2 times of this moles, 338 R. Right? So my moles in this condition will be 2 times of these moles. Now again I will apply the PV equals to nRT equation to find the pressure. So pressure is the final pressure PF. So PF, volume remains the same V because volume is same for the container, it's a rigid container. And N is now by this moles. So 2 times 25.5 into V over 338 R multiplied by this R and T. Right? And what is T here? T is 480 Kelvin. So I change T to 480 Kelvin. T is my 480 Kelvin. So now what will happen? R will cancel out, right? V will cancel out, and we just solve this and we will get final pressure in the container. So what is the final pressure? 2 times 25.5 multiply 480 divide by 338, 72.4. So yeah, kilopascals, right? So how many significant figures we have to report? This is my 3 significant figure, this is my 2 significant figure, and this is my 3 significant figure. So I will report my answer in 2 significant figure. So my answer should be 72 kilopascals. So this is my answer, final answer. Okay, so the question is flask X contains 1 dm cube of helium at 2 kilopascals pressure, and flask Y contains 2 dm cube of neon at 1 kilopascal pressure. If the flasks are connected at constant temperature, what is the final pressure? So I have 2 flasks. One flask, this is my flask X, and the volume here is 1 dm cube. Okay, I have another flask which is of 2 dm cube. 2 dm cube. Okay, and this is my flask Y. Flask Y. So the pressure in the initial flask X is 2 kilopascals. In the flask Y, the pressure is 1 kilopascals. Okay, here I have helium and here I have neon. Now what I am going to do, if the flasks are connected at constant temperature, so temperature is constant, T is constant. Now I am going to connect this flask. So I will connect the flask. So when I connect the flask, they are asking what is the pressure, final pressure. So when I connect the flask, what is the pressure? We need to find the pressure here. In this, pressure is what? So when I connect the flask, the volume will be added up, right? V in this flask will be volume of this flask plus volume of this flask. So 1 plus 2, that is 3 dm cube will be the volume, right? Temperature is constant, temperature is T. Now in this flask X, what is the moles? So the moles of the gas in flask X and the moles of the gas in flask Y will be added up, because when we are adding this, means 1 kg banana plus 2 kg apple, we add up together to put in these two in this container. So here what is the moles? So moles equals to, we use the ideal gas equation, PV equals to nRT, right? So and find the moles in flask gas. So my moles will be N equals to pressure into volume. Pressure is 2 kilopascals into volume is 1 dm cube, divide by R and T. T is constant, right? And R is constant. So this is my moles of helium. What is the moles of neon? Moles of neon will be pressure into volume over R and T. T is constant. Now here we have helium plus neon. So the moles of helium plus neon, so total moles will be 2 multiply 1 over RT plus 1 multiply 2 over RT. So that will be 4 over RT, right? 4 over RT. So in the final condition, we will apply again the ideal gas equation, PV equals to nRT. So P we need to find, P final we need to find. What is the volume? Volume is 3 dm cube of the final flask, and N, how many moles are there now? This much total moles, 4 over RT and this R and this T remains the same, R and T. So what, we can cancel out RT, so cross multiply, we will get P final equals to 4/3 kilopascals. This is the answer.